Hello everyone, I am Pavitra. Now I am explaining about data analysis assignment. In this assignment, I take placement data set. Let's go to the coding part. First, import pandas. Pandas is a library. It is used to read CSV file and create tables, etc. And then we create short form for pandas as PD. Uh, so we use as PD and then we read the CSV file. The variable name is dataset and then print the dataset. We have some features like gender, SSLC postmark, SSLC board, etc. And then the next is we check null values or none values in our dataset. So we use is null. To check null values, and then sum is used for in a column we sum number of none values, so we use sum, and then in our data set only salary column gets 67 null values, so remove the null values. We done pre-processing the data. In pre-processing data, 4 methods are there: replacing the missing value with central tendency and or entire row delete, respected to the problem statement how to replace the missing value. And then consider this and semi-supervised create a model so that we can predict the missing value. These are the method, but in our data set we take how to replace the missing value, because we have only none values in salaries. So not placed students only get that none values. You can see, not placed not placed student cannot get salary, so we replace the missing values with a 0. Okay. We use fill now, replace the none values with 0. In place equal to true is for we did not create a variable name. So after the changes in data set, we can store the changes in that data set. So we use in place equal to true, and then after the data pre-processing, we check any other null values is there. So we use after is null function, and then there is no null values present in our data set. Our data set is move to clean data set and then print the data set. You can see not placed students get a salary 0. The missing values are replaced with the 0. And then the next question is how many of them are not placed. We have in our dataset status column have placed and not placed students details. So we take status column and count the number of values in not placed. So we use value counts. We get output 67. 67 students are not placed. And then the next question is find the reason for non-placement from the dataset. We analyze this question. Reason for non-placement student. So we split the data set placed student and not placed students. So I take this data set table from data set of column status column name, not placed students. In the column not placed students, we split, and then and then I split a qual. Quan means numerical data. Qual means categorical data. In quan we get marks, pass marks details, and in qual we get board details, and then specialization details, etc. And then we calculate median. For that, using median we can analyze what's the reason. So I calculate median for that column. Quant columns. This is our not placed student median values. First, um, I split the non-placed students data set, and then I create a function qual, and then create quant list and qual list using for loop. Get column names, data types equal to string. That means SSLC board, and then the string data types are string. So I use this method. Um, if the condition is true, append the column name in qual. If the condition is false, append the column name in quan. And then return qual. We get two lists. So I create variable quan and qual, and calling the function. And then print the quant list. We get the numerical data columns, serial number, SSLC postmark, higher secondary postmark, etc. And then I calculate the medium. So first of all, I create a table. So I use data frame. And then columns equal to quan index. Our index is median, so index equal to median. The first data frame first gives the row name and then gives column name, and using for loop, dot median is for calculate. Dot median is for calculate the median. We use a median function as usual, and then we print the median values for quant details. Um, as same as the above not placed student, what steps are we are done. Same here. First we split the placed student details, and then create quant qual function and split the quant qual details, and then and also we create calculate the median values. In the comparing these two values, we have some reason why they are not placed. In SSLC postmark, the placed student gets 72.5. And then here not placed student 56.28, higher secondary 60, degree postmark 61, 67, 60.69. These are not placed students details. These are placed student. Comparing these two, up to SSLC mark to E-test mark, the average is less than 68% in not placed student. So below a 68% pass mark students are not placed. In placed student up to SSLC mark to E-test pass mark, they get above 68%, so they are placed. This is the reason. And then the next question is, what kind of relation between salary and MBA postmark? So I take correlation. Correlation is nothing but relation between two columns. So we find the relation between salary and the MBA postmark. So we use dot core for to perform the correlation. We use dot core. Comparing this first salary. So this take salary take as a row, and the MBA postmark take as column. Salary. This is MBA postmark. We get 0.13. So it is considered as positive correlation, and 13% directly proportional to MBA postmark. And then the next question is, which specialization is getting minimum salary? For this, we short the data set to get minimum salary. So we short the values in our data set. Mm, uh, no. Data set. We take only play student, so because play student only get salary, we don't want not play students, so I get only play students details. So I from salary column I short the values in ascending order manner. Ascending equal to true means we get ascending order manner. Ascending equal to false means we get descending order. So I get ascending order only. I want ascending order only. So I get ascending equal to true. Now first minimum salary is 2 lakh. Which specialization? Marketing and HR and marketing and finance are getting minimum salary. Okay. And then the next question is, how many of them getting above 5 lakh salary? For this, mm, take the column name. This data set for from the table I get data set from that column name. So I put data set in this also from that column name greater than 5 lakh. From that column salary column, who get greater than 5 lakh. So we use this greater than 5 lakh. Only 3 can get greater than getting above 5 lakh. Value dot count is count number of rows is there. It is this is not necessary for this, but if you get big data set, we can use dot count. And then so 3 of them getting above 5 lakh salary. And then the next question is, test the analysis of variance between e-test passmark and MBA passmark at significance level 5%. Made decision using hypothesis testing. I take ANOVA in one way. So from stats, we perform ANOVA one way. We use ANOVA one way, F underscore one way to execute one way, and then first put the we put the column name e-test passmark and the MBA passmark. Our result is p-value 4.6, but below 5% it is it it is there is a significant between this column, but it is 4.6. It is above 5%, so there is no significant between this column. So it accept H0 and reject H1. H0 means there is no significant between this column. H1 is there is significant between this column. And then so analysis of variance, p value is greater than 5%, so accept H0 and reject H1. And then next question, test the similarity between the degree test, science and technology, and specialization, marketing and HR with respect to salary at a significant level of 5%. Make decision using hypothesis testing. I take t-test. So in t-test there are unpaired t-test we take because we have different groups degree test and specialization, so we take different groups, same condition, but same condition is salary. From stats we import a t-test and as usual drop the null values, and then we create variable for degree T and salary, and another variable for specialization and salary. The variables put inside the function t test, we get the values. P value is less than 5%. So it accepts the alternative hypothesis and reject the null hypothesis. The statement is test the similarity between the degree T and the specialization with respect to salary. Mm, so we get alternative hypothesis. So there is similarity between degree T of science, technology, and specialization of marketing and HR. And then the next question is convert the normal distribution to standard normal distribution. And then the next question is convert the normal distribution to standard normal distribution for salary column. So as usual, we create a function and then Cburn is for display the graph, and then calculate mean and standard deviation, and using for loop we get the column names. And then this is the formula calculation. KD equal to true is kernel density function equal to true. This is for the curve display. Equal to false means the curve is not displayed, and then as usual formula, and we call the function. We give input the salary column, and our graph look like this. This curve, this bell-shaped curve is not placed students. They are zero. We put 0, and then this is placed student curves. The perfect, it look like perfect bell-shaped curve. The normal distribution function also the look like standard normal distribution curves also look like bell shape or similar. And then we move on next question. What is the probability density function of salary range from 7 lakh to 9 lakh? So we create the function get PDF probability, and then matplot library. Matplot library is for a graph plotting, and then we use scipy.stats for because the inbuilt function normal distribution inbuilt function or input this library, and then we use cburn as usual to display the graph, and then KD equal to true for display the curve, and then our background color is green, and then the curve color is blue, so we use color blue. And the start range color is red, and then end range is red color as usual. And then we generate a data set and then calculate the mean and the standard deviation as usual. And the norm is for a norm function. It is a inbuilt normal distribution function, and we give input parameters as sample and mean and the sample STD. And then we use one liner for loop, and then as usual we print the start end range and probability. Sum function use inbuilt sum function, and then uh, we call the function and give salary column as input because our question is the probability of 7 lakh to 9 lakh. So we give salary column, and then our probability graph look like this, and then the range 7 lakh to 9 lakh is this line. This is start range and this is the end range. And then the next question is test the similarity between the degree T and science and technology with respect to E-test pass mark and MBA pass mark, that is significant level of 5% make decision using hypothesis testing. So we did t-test. T-test, it is a paired t-test. So same group is degree T, but different condition. Different condition is e-test pass mark and MBA pass mark. As usual, we import t-test from stats and then we create, as usual, drop the null values and then we create a variable for degree. T e-test pass mark and degree one for a variable. For degree T and MBA postmark, as usual, we call the inbuilt function for T testing and parameters of degree and degree one. Probability is greater than 5%. So it is so there is no similarity between e-test postmark of degree T and the MBA postmark of degree T. So it accept the null hypothesis and reject alternate hypothesis. Mm, Null hypothesis means there is no similarity between e-test postmark of degree T and the MBA postmark of degree T. And then the next question is which parameter is highly correlated with the salary? For correlation, we use this function correlation inbuilt function. Compare. So we compare that. Mm, mm. So salary, they said salary highly correlated with salary. So SSLC pass mark is highly correlated with salary because it is 0.53. Other sorry, this is sorry. Higher secondary pass mark is 0.45. Degree pass mark is 0.40. ETS pass mark is 0.18 and 0.13 MBA pass mark. So we take SSLC pass mark and then plot any useful graph. I take a pair plot. It compares the each rows and columns. Serial number to serial number, SSLC pass mark to SSLC mark. This is look like correlation. It that gives only numbers. This look like graphs. So this is the pair plot of this data set. And then that's all. Thank you.